In this next video, let's revisit the animals data set that we opened. Remember, we read in, we had this brain and body weight CSV files, and actually I've still got the, well, let's see. Animals. Okay. I've still got the, it looks like I've still got the Brachiosaurus and the Diplodocus and the Triceratops and the elephants in there. I want to get rid of those dinosaurs, okay, and maybe I'll get rid of the humans too. Remember we did that before, and okay, and so now I plot. There we go. Now I've just got the animals. No dinosaurs, no elephants, no humans. Okay. Now this is looking a little bit better. Remember that those large animals are they're way off to the right and way up. You know, the humans were way up here. So we've sort of zoomed in down in that lower left-hand corner of the original scatter plot. And now, and so we're just going to focus on some animals that that sort of make sense as a group. Now, maybe I'll add some labels and do a linear model with the next couple lines here. Okay, and you can see that I've got my labels and done a linear model. I can see what that linear model output looks like. Here my intercept and slope, and my p-values are small. It's good. They're indicating these values are likely not zero. My r-squared value is 0.7893. So that's good. Let's notice, however, that even though that r-squared value is high, that may be largely due to the fact that there are a bunch of animals down in here, and they're going to tend to get close to the line period just because they're so concentrated there. You can see, however, that there's sort of this fanning out, right? As you move, as the body mass gets larger, there's still sort of this fanning out behavior. What we can do a lot of times is take data transformations. If we don't satisfy that line assumption, then what we can do is somehow transform, subject either one or both variables to some transformation. So I tell you what I'm going to try in this case, and this takes experience sometimes. You can read more in your book about transformation functions, but I'm going to try taking the natural logarithms of both variables. I can do that with the log command. All right, so so I'm going to create these new columns in my animals data set. See, called log brain and log body. So here are their body masses and brain masses, and then in the next two columns I got the logs of their brain masses and the logs of their body masses, natural logs. Okay. Now let's just see what happens if I do a linear model on the log of the brain masses versus the log of the body masses, and then do summary of that. My r-squared value has increased quite a bit. Let me make a plot and drop a regression line down. Okay, like so. Okay. Now take a look at that. That's pretty amazing. From this to this. Okay. Now you have to be careful here. It looks like there's a nice linear trend here, but what this is saying though is that there seems to exist a nice linear trend between the log of the brain mass versus the log of the body mass. Okay, so the linear trend is no longer on the original variables, it's on the logs of the original variables. Now I can also do the lack of fit test there. if I like, and well, let's see, what's my like a fit p-value there. I guess it's right here. It's not small, so my lack of linear fit test is that's indicating good. It's that it's not inconsistent with a linear fit. Let's get a new window and plot the log of the body versus or plot the residuals from the logs, from the log plot against the logs of the body masses. Okay, so just eyeballing this doesn't appear to be, I mean, this one may be a little out of the ordinary, and maybe this one is too, but it doesn't appear to be like there's any non-normality or non-constant variance or real overall trend there. I could certainly run some tests for that, like for checking for normality. I could do that, maybe look at a histogram of the residuals. Take a look at a plot of the residuals versus, well, actually that's just what I had there, isn't it? Let's take a histogram of the residuals. Okay, and that's not inconsistent with a normal histogram. Okay, and finally, maybe I'll go ahead and do a Shapiro-Wilks test to check for normality on the log of the residuals, and the p-value is not small, so that's good. That's indicating that maybe what we want to consider then is a relationship between the logs. So again, what we've done here is we've transformed each one of these variables. We've transformed the values according to some function, and what function you pick sort of depends on what kind of shape your data are taking on. Are they sort of moving over this way? Are they trending that way? Are they fanning out in a certain way? And you should definitely take a look at some of the pictures in your book on this.